YouTube link also, and the attendance for that. Okay, so in the through the YouTube chat box, the attendance will be collected. So need not worry. I think almost another 100 participants they are waiting outside. So they will be joining by YouTube link. Okay, so you need not worry about any hiccups. I think there will not be any problem. Okay, so we have made alternate arrangements. So we thought that if at all excess participants are there, we are engaging them through YouTube live streaming. Okay, so we will go to our discussion. So I'm going to start my presentation. Okay, so I'll just make my. I will present my screen. Just one. First of all, am I audible to everyone? So first I want to know. Swati, am I audible for everyone?
Yes, sir.
Okay. Okay. Then I will proceed with my discussion. Swati, are you able to see my presentation?
Yes, sir.
Okay. So we will start our presentation. So I welcome everyone for this 2-week online workshop on energy simulation and the CFD analysis in buildings. So what is the scope of this workshop? The scope of this workshop is to tell you about the background information about the energy simulation solvers. So about the energy simulation solvers and solving the problems, I think you can. There are a lot of materials available in YouTube, and a lot of manuals are available. I think you can learn. But the background information about the energy solvers. Okay, so that I think it is very important to, for everyone to know. So the main scope of this workshop is to tell you about the background information about the energy simulation solver. So in general, okay, so what we are planning to discuss is building energy simulation analysis and the CFD. Okay, so we had planned this workshop in such a way that we have to tell everything in and out about the building energy simulation software. With the CFD also. Okay, so now latest building energy simulation softwares, so they are coming with the CFD analysis also. So we are going to discuss in depth about the even CFD simulation software also. Okay, when first of all going to building energy simulation models, so we will be having several inputs. Okay, so like we will be giving the solar data, geographical location, building orientation, ambient temperature, the material properties. So all these things we will be feeding to the building energy simulation model. So the output what you will be getting, it will be building indoor temperature variation, total heat entering into the building, temperature variation along the building wall thickness, the energy consumption per day, energy consumption per month, or energy consumption per year. So all these informations will be the output, will forming the output of a building energy simulation model. So in order to cater all these things, we have designed the workshop. Like first topic, we are discussing about sun position and climate, because you may be knowing all these building simulation softwares. The input will be the climate model. So climate model means we have to talk about the solar energy which is entering into the building. Then we have to talk about the ambient temperature. Then we have to talk about the moisture, humidity which is entering into the room, the wind velocity. So all these things will be forming the input to the building energy simulation software. Okay, so that is why we are having a separate discussion on sun position and the climate. So the next is we will be talking about the heat gain and heat loss in a building. So most of us, okay, so most of us who are attending this program. So we will be attending from India. So we are there at north latitude. So we are between 10 degrees north latitude and 10 to 20 degrees north latitude. Okay, so that means we will be learning building energy simulation software specific to our locations. If you are asked to design a building at a different location, for example at China, okay, and or in Scandinavian countries or in US, so then the discussion should be different. So in this workshop, so it is not it is not localized. The discussion is not localized. So we are discussing about the situations at various locations. Okay, namely it can be in the north latitude, or it can be in the south latitude, or somewhere. Okay, so all these discussions will be held. So accordingly, we have a discussion on summer air conditioning as well as winter air conditioning also. Also, we will be touching the basic psychrometric and air conditioning load. So all of you might be knowing. So the air conditioning load estimation and the building energy simulation both have the connection. Okay, so we are calculating the building energy, okay, or the load for particular day, but the energy calculation we do it for a particular span of time, maybe for a week, for a month, or for a year. So that is how we work out. Also, we are going to discuss about energy simulation procedure. So what is the fundamental behind the energy simulation procedure? What are all the equations we are solving in an energy simulation procedure? And we are going to discuss about heating and cooling design. So mostly in India, we will be discussing about cooling design. No, here we are going to discuss about heating design also. We are going to discuss about year-round simulation. Okay, year-round simulation, and what are all the aspects we have to take into consideration for year-round simulation. Also, advanced concepts like PCM integration in buildings, and as well as CFD basics. Okay, nowadays all the CFD, all the energy simulation softwares, it is coming with the CFD. So that means we have to focus on the CFD basics. So we have to concentrate on external CFD, internal CFD. Also, we are going to complete our discussion with the comfort indices in CFD. So that is how we have planned. Okay. So in the morning, there were few questions from the participants in the WhatsApp group asking whether we are going to teach any software. So we are not going to teach any software. Teaching a software, it is very easy. So if you want, we can assist you. Okay. So the softwares like a Design Builder and other softwares, it is available. It is available free for monthly basis. Okay. So on trial basis, it is available free, and the even videos are also available. Okay, in YouTube. So we can assist you. Okay. So you can learn it by yourself. Okay. But what we are going to discuss, it is one step ahead of that. So we are going to discuss what is the basis behind the design of this software, and what is the basis behind this the CFD. So all these things we are going to discuss. As such, I can assure you that the discussion will be very interesting. Okay. Okay. This is the thing. And anything, any question or any query, so we can post it in the chat box. We can have a discussion at the end. So now I will proceed to the first topic. So the first topic is sun position and climate. Okay, so my name is Dr. Anthony AROUL. So most of you might be knowing. So I'm professor in Department of Mechanical Engineering. So at Ishrae Engineering College, Chennai. Okay, sun position and climate, it is very, very important. So for understanding the fundamentals behind using the energy simulation software. Okay, so if you don't understand the sun positions and the climate, so it will be very difficult for us. So all along we are going to discuss various climatic parameters, and also I will try to underline what is the importance of these climatic parameters in the building energy simulation software. So the overview of today's presentation is we are going to discuss about latitude, longitude, tilt, and also we are going to discuss about rotation of the earth around the sun. We are going to discuss about equinox and solstice, seasons, sun path diagram, and what is the takeaway from today's discussion for a building simulation engineer. Okay, so the first is latitude, longitude, and the tilt of the earth. Okay, so most of you may be wondering, so latitude and longitude. So it is a very preliminary discussion. So why it has to be discussed today? But we should understand that latitude is an important parameter. Okay, so the climate changes. Okay, the local climate changes with the latitude, and the longitude is also an important parameter. So the daily variation, diurnal variation, it is dependent on the longitude, and the tilt of the earth, it is totally responsible for the climatic changes throughout the earth surface. So that is how this latitude, simple definition of latitude, longitude, and tilt, it becomes an important parameter. Today we are going to discuss more about this latitude, longitude, and tilt of the earth. So first of all, what is the latitude and the longitude? So latitude, okay. So first, latitude and longitude, why it is required? So when we are working in a graph, so all of us definitely we might have one point of time we might have worked in a graph sheet. Okay, so in the graph we will be having the x-axis and y-axis. Okay, Suppose inside the graph, you want to locate any point, how you will be locating? So we will be locating that by using the x coordinate and y coordinate. Okay. So similarly, if you want to locate some point in the Earth surface, so we need to have a graph like position. So that means we should have a x coordinate definition and y coordinate definition also. So here latitude and longitude comes for our help. So latitude, it is like the y-axis, okay, and longitude, it is like a x-axis. So, but the surface is not flat. When you are drawing a graph, the surface will be flat. But when you are going to the on the surface of the Earth, the surface, it is going to be spherical shape. It is not purely spherical shape. So it is nearly spherical shape. Okay. So for locating any point on the surface of the Earth, so we have latitudes. So latitudes are the horizontal circles that you can draw along the circumference of the Earth. Okay. So these are all the geographic coordinate which will be specifying north and south position. So that is like y coordinate. Okay. So latitude, it will be varying from 0 degree to 90 degrees. So 0 degrees will be at the equator. Okay. And if you are traveling towards the north, okay, so it will be going from 0 degree to 90 degrees. Okay, at the poles. So similarly, it will be having another 0 degree and 90 degrees from equator towards the south pole. So accordingly, we call, so for example, I can call 40 degrees north latitude. That means it is in the northern hemisphere. So similarly, if it is 40 degrees south latitude, it is in the southern hemisphere. Okay. So from 0 at the equator, we will be moving towards up. So we are going to have a discussion on that. And the next is the longitude. So longitude will be like vertical lines. Okay. So and vertical lines. Okay. So it is for locating in a horizontal way. Okay. It is for locating in the horizontal way. In the horizontal direction, so you will be having a circumference. So that angle subtended by that circumference will be 360 degrees. So that means we have to divide that 360 degrees. So we are dividing that 360 degrees in multiples of, so you can have it in multiples of 1 degrees. Okay. So that means 360 degrees, we are breaking it into minus 180 and plus 180. So one direction we call it as 180 degrees east, and the other direction we are calling it as 180 degrees west. Okay. So for locating, okay, any point on the Earth surface, both latitude and longitude is required. Okay. So this is the picture. So when I tell something pictorially, so it will be very clear for you. Okay. So if this is the Earth and this is the Earth surface. So the line what I have it here, okay. So the line what I have it here. So this is called as the equator. Okay. So this is 0 degrees. So this is called as the equator. So as I move up, okay. So the first line, it is 10 degree north latitude. So the next line, it is 20 degrees north latitude. So the third line, it is 30 degrees north latitude. So it is going like this. So it is like a graph only. You can see it is like a graph only. So this is 40 degree north latitude. This is 50 degrees north latitude. So like that, I will go up to 60 degrees north latitude. So you'll be having at 90 degrees at the poles. Okay. Similarly, when I come to the south, here it is 0 at the equator, 10 degrees south. So then 20 degrees south. Then I have 30 degrees south. Then 40 degrees up to 90 degrees at the poles. Okay. And we have some important lines that we have to understand. Okay. So when the latitude is 23.5, there is a special name for that. If it is 23.5 north, so we have a special name for that. That is called as Tropic of Cancer. So when the latitude is 23.5 south, so we have a special name for it. It is called Tropic of Capricorn. So thus, if the angle is 0 degrees, it is equator. Okay. And if it is 23.5 degree north, it is called Tropic of Cancer. So if it is 23.5 degrees south, so it is called Tropic of Capricorn. And we have two circles. One is called Arctic Circle. So it is almost around 66.6 degrees. Okay. In the north. Similarly, we have Antarctic Circle. So it will be 66.5 degrees south latitude. Okay. And we have to know about the tilt of the Earth. So the Earth is tilted at 23.5 degrees. Okay. Earth is, while rotating, the axis of rotation is tilted at an angle of 23.5 degrees. Okay, so it is not rotating on a vertical axis. It is rotating on a inclined axis. The axis of inclination is 23.5 degrees. So that is very much responsible for all the climatic conditions which we are having it in the earth surface. So tilt of the earth, it is a very important parameter. So because of that only we are having the climatic variation on the surface of the earth. So that is what we are going to discuss in detail. So when we are going for latitude and longitude, so we should have a feel, because already I told you. So we are not working on a localized way. We are not working for India alone. So if you work for different countries, first of all we need to know what are all various countries at different latitudes. So when we go to the equator, so we find the north of South America and Africa, mid of Africa, okay, and few islands, okay. So we have it at the 0 degrees, so that is equator, okay. When I go for 20 degrees north latitude, okay, so I have Mexico. I think it is Mexico. Next, I have North Africa, and I have the Gulf, and I have India. Okay, already I told you. So we are moving from 10 degrees. Okay, when in the bottom we will be having around 10 degrees. So here we are having 20. So maximum we will be going up to 30 degrees north latitude. Okay, 30 degrees. So because it is India, we have to specially know about this. At the bottom we will be having near 10 degrees, and this is 20 degrees. Tropic of Cancer will be there here, somewhere here. Okay, near Allahabad. So that is 23.5 degrees. So here I will be having 30 degrees. Okay, so here I will be having 30 degrees. Okay, and in the 40 degrees north latitude, so we have North America. Okay, so north of North America, and I have South Europe, and I have China. Okay, so this is there at the 40 degrees. Similarly at 60 degrees, okay, so I have the Canada, I have North Europe, okay, maybe Italy, and Russia. Okay, so all these things are coming at the 60 degrees. So most of the countries, okay, so you are finding that most of affluent countries, it is coming between 20 degree north latitude and 60 degrees north latitude. And coming to the south, 20 degrees south latitude, we are having central South America. Then I have South Africa. Then I have North Australia. And 40 degrees south latitude, I have south of South America. Then I have the south of Australia. Okay, so these are all the locations. Okay, so these are all the locations, because already I told you the climatic condition depends on the latitude. So that means when I talk about a country, immediately that latitude should strike you. So then only you can understand their climate. So that is why I've given a separate slide for knowing the latitudes of different locations of the globe. So, okay. Next thing is the Earth is rotating around the sun. Okay. First, Earth rotates itself. For the Earth to rotate itself, it takes 1 day. That we should know. 24 hours. Okay. The Earth rotates itself. Okay. So that for that it takes 24 hours. So that is we call it as a day. And also the Earth rotates around the sun. When the Earth is rotating around the sun, so it takes approximately 365 days. Okay. So 365 days, Earth makes one complete revolution. Okay. So that means when the Earth is rotating around the sun, so we have some salient positions. Okay. So this position, okay, so this position, we can have the Earth. Okay, Earth can move like this. Okay, so it can rotate like this. Okay, so that means we have some salient positions. So this is one position. We call it as December. Okay, December solstice. Okay, December solstice. I will explain you afterwards why we call it as solstice. So similarly, if the Earth is on the other extreme position, we call it as June solstice. Similarly, if Earth is at this location or this location, I call it as equinox. This I call it as March equinox. Okay, March 22 equinox. Here I call it as September 22 equinox. Okay, so this is about the rotation of the Earth around the sun. Okay, so the location what shown to you, it is December 22 solstice. Okay, and similarly, if the Earth is in the opposite position, so this position it is called as June 22 solstice. Again, I am telling you, December 22 solstice or June 22 solstice, it is not telling anything about the climate. It is just telling about some position of the Earth relative to the sun. So that is what we have to understand. Okay, and this is the full picture. Okay, so here we can see these are all the various positions. So This is the axis of inclination of axis of rotation of the Earth. Here you can see it is tilted at 23.5 degrees. So here also it is tilted at 23.5. So while rotating, so this will be rotating like this is rotating like this. Okay, so it will going around the sun like this. Okay, so already I told you. So these two positions, it is called as solstice position. So this is a December solstice position, December 22 solstice position, and this position it is called as June 22 solstice position. Okay. Similarly, this and this position I call it as equinoxes position. So this position it is called as March 22 equinox position, and this position I call it as September 22 equinox position. So you may ask, what is a solstice? Okay, solstice is very simple. It is the extreme positions. Okay, it is the extreme positions of the sun. Okay, we call it is in most northerly. You could call it as most northerly or most southerly positions. Okay, so here the sun is at the most southerly positions, and here the sun is at the most northerly positions. Okay, so that is why it is called as solstice. Okay, so December 22 it is called as a solstice. Okay, December 22 solstice. Okay, so in simple words, if you want to understand, very simple words, so the sun will be nearest to Capricorn. Okay, that is colloquially telling, sun will be nearest to Capricorn. So that is called as December 22 solstice. Similarly, if the sun is nearer to Tropic of Cancer, so that is called as June 22 solstice. Okay, two solstice positions are there. Okay, similarly we have equinox. From the name itself we can understand. So it is telling something is equal. Okay, so here when the Earth is rotating, okay, first and foremost we have to understand that this position, okay, the sun will be nearest in this position. Okay, nearest to the Tropic of Capricorn in this position. So please note, from this point to this point the sun is at the nearest position. Similarly, at this point it is the sun is nearest to the Tropic of Cancer. So from this point to this point the sun is nearer to Tropic of Cancer. But just if you think, even the sun is in this position, okay, so you will find that the axis, okay, axis of rotation, it will not have any effect, because the axis of rotation it will be coinciding with the line separating the day and night. Okay, the line separating the day and night. So because of that, what happens? So you will be having equal day and night. So that is why it is called as equinoxes. If I tell like that, you may be finding it difficult. If I show it pictorially, then you will be in a better position to understand what is an equinox. Okay, so equinox, it is the position where, in simple words, these four position how to understand. Okay, so here the sun is near the Capricorn. This is the first position. Okay, December 22 solstice, sun is nearer to Tropic of Capricorn. And this second position, the sun is nearer to equator. Okay, and the third position, the sun is nearer to Tropic of Cancer. And the fourth position, again the sun is nearest to equator. So that is why when the sun is nearer to equator, you will be having equal day and night position. So that is why it's called as equinox. We will have a better understanding when we go to this picture. Okay, okay, so first we will go to the first position. So I told the four positions are very important for understanding about the climate. So the first position is December 22 solstice. Okay, the December solstice 22 solstice, it is the moment at which the center of visible sun is directly above the Tropic of Capricorn. Already I told you. So the sun's direct rays will be directly on the Tropic of Capricorn. So this position is called December 22 solstice. So when how it will be in reality, how this will be looking. Okay, so this axis, red color axis, whatever it is shown, it is the axis of rotation of the Earth. Okay, and this is the light. Okay, so this is the light which is falling from the sun. So the parallel rays from the sun, it is coming, and here you can see that the parallel rays from the sun, it is making 90 degrees to the tangent drawn this place. Okay, to the tangent drawn to the Tropic of Capricorn. So when it is making 90 degrees to any surface at the surface of the Earth, so then it will be having maximum amount of radiation at that point. Okay, so at this point you will be having maximum radiation. Okay, and another most important thing what you have to understand is, while the axis of rotation is this red color, okay, this red color, so the sun will the Earth will be rotating in this red color axis. Okay, but you see the line separating the day and night, line separating the day and night, but it is vertical. Line separating day and night, it is always vertical. Okay, so it is always vertical, but the axis of rotation, you can see it is inclined. So because of that, what is happening? So south, so you can know this is equator, this is Capricorn, this is Tropic of Cancer. So now there is more solar exposure at the south and less solar exposure at the north. So at the December 22 solstice, what is that we are finding? There is more solar exposure at the south and less solar exposure at the north. And because of that, what is happening? So you are finding that the day length. Okay, so here you know, so since Earth is rotating about this axis, okay, so you will find this line from this point to this point. You are finding day portion, it is taking more length, and night portion, it is having less length. But the equator, it is always equal. So then we go to Tropic of Cancer. What is happening? So the day portion, it is having less length, and the night portion, it is having more length. When I go to the Arctic Circle, what is happening? Totally, it is like a night. Okay, when you go to the poles, it is 24 hours, it is dark, and when you are coming to the South Pole, it is 24 hours, it is day. Okay, so that is what we have to understand. And also, most important thing, so all these things I think I have mentioned already. The angle made by the parallel rays from the sun. The angle made by the parallel rays from the sun, it is making 90 degrees at the Tropic of Capricorn. So here I will be having maximum radiation, and it is making 46.5 degrees at the Arctic Circle, 23.5 here, and at the equator it is 66.5. And what is that you are finding on the Tropic of Cancer? Tropic of Cancer, I am finding that you have the angle is very much lesser. Here also the angle is very much lesser. So lesser amount of radiation alone, we will be having it at the North Pole. So when you are dividing the Earth into the northern hemisphere and the southern hemisphere, northern hemisphere is getting lesser radiation. Southern hemisphere is getting more radiation during December 22 solstice. Okay, so that is what we have to understand. Okay, how we can say that this is getting the surface which is directly coming, it will be getting it will be concentrated on a smaller area. But if your surface direct sun, if it is coming and falling on an inclined area, so it will be covering a large area. So that is what is happening here. So here you can see here, when it is coming for a smaller area, the radiation will be more. But the same radiation, when it comes here, the projected area will be more. When the projected area is more, it will be falling over a longer area. So what happens? The amount of radiation will become lesser. Okay, so that is why December 22 solstice, you will be having a smaller amount of radiation. Okay, smaller amount of radiation in the northern hemisphere and large radiation in the southern hemisphere. Okay, so for understanding that only I put this diagram. Okay, so this is because of the angle made by the tangent drawn with the sun's rays. Okay. Okay, so what else happens at the December 22 solstice? In the December 22 solstice, we are finding that the North Pole is totally in the darkness. Okay, North Pole, sorry. Okay, I think there is some mistake. Okay, so the North Pole will be totally in the darkness, and the South Pole will be totally at the daylight. Okay, so I think there is some mistake here. Okay, okay, so that is what we have to understand. Okay, so next, most interesting part is the day's length. Okay, day's length. So already discussed. Okay, so what is happening at the South Pole? The South Pole, we are having 24 hours of daylight. Okay, so we are having that means there is no night at all. Okay, there is no night at all during December 22 solstice. There will not be night in the South Pole. Okay, and what is that we are having? So when you are coming to Tropic of Capricorn, okay, so the day length, you are finding it, this portion exposed to day, this length from here to here, it is higher compared to here to here. So because of that, the day length whatever I'm having, it is 13 hour, it's almost 13 and a half hours, 13 hours 27 minutes. So what will be the night length? Night length will be 10 hours 33 minutes. So that is what I am having. So more radiation and more dilated in the southern hemisphere. Okay, when I am crossing the equator, it will be always equal. equator, the day length will be always, day length will be equal to the night length always. Okay. So when I'm going to the Tropic of Cancer, so I find that the day length is reduced. The day length is reduced and the night length is increased. Okay. Day length is 10 hours 33 minutes and the night length is 13 hours 27 minutes. So that is exactly opposite to what we have it here. Okay. And when I am going to the Arctic Circle, so in the Arctic circles, I have the day length of 5 hours 31 minutes. Okay, it's very small. Okay, a day's length is 5 hours 31 minutes. So whatever the night length, night level is it's 18 hours 29 minutes. So that is how we have it. Okay, so why I'm talking about the December 22 solstice, because we are familiar with the December 22 solstice because we will be having winter. We are living in the northern hemisphere. So most of us in India, so we'll be familiar with December 22 solstice, okay, in the northern hemisphere, okay. So we will be having a smaller day length during in the month of December, okay, in the north latitudes, okay, but it will not be as small compared to China and other Scandinavian countries, which are there at 40 degrees north latitude. Just now we have discussed, okay. So you may ask why I need to know about all these things, okay. You are an energy simulation engineer, so you need to know about the day's length, because whenever you are making a simulation, so always you should not think that you have to simulate from morning 6 a.m. to evening 6 a.m. So that should not be the case, okay. So you should know the day's length. So knowing the day's length, we have to simulate it, okay. So if your day's length is going to be 13.5 hours, so that means you have to start your simulation, okay, or you have to conduct your simulation for a span of 13.5 hours, okay. So that you will understand only if you know about the day length. So that is the purpose of this today's discussion, okay. Okay, so we know about the December 22 solstice. So December 22 solstice, it is winter in the northern hemisphere. But what about the south? It is summer. It is summer in the southern hemisphere. That is very, very important. That we should know, okay. So we are familiar with the winter in the northern hemisphere. We are living in the northern hemisphere, so we know that December 22 will be a winter in the northern hemisphere. But the same time we will be having summer in the southern hemisphere. Okay, so that is very important. That we should know. Okay, so this is about the December 22 solstice. Next, we have to go to the equinox. Okay, so already I told you. So this position. Okay, so these two positions are called as equinox positions. You will be having equal day and equal night. And also I told what is the reason for this equal day and night, because you think when the sun is at this position, it will be nearer to Tropic of Capricorn. So when the sun is at June 22 solstice position, it will be nearer to Tropic of Cancer. When the sun is at this position, it will be nearer to the equator. In two equinox position, it will be nearer to equator. And other things, the tilt of the earth, it will not have an effect on the day's length, because the axis with which it is inclined, okay, so it will be coinciding with the line which is separating day and night. Okay, for having a better understanding, you can go through this picture. Okay, so here you can understand. So this is December 22 solstice position. So we are discussing about the equinox like this only. Okay, but for understanding, I put this diagram like this. But the real thing is this vertical, this red color axis, it will not be like this. This red color axis, it will be pointing towards you. Think that the red color axis, if it is pointing towards you, if there is any inclination, okay, is it possible for you to understand? No, it is not possible, because this is the top view. This is the top view. This should be the top view. So in the top view, this red color line, okay, this red color line, that is the axis of inclination of the earth. So that will be at the top. So even if it is inclining, okay, even if it is inclined, okay, that will be coinciding with this axis. So the axis of rotation is coinciding with the line separating the day and the night. This is the line separating the day and night. So the axis of inclination is coinciding with that. So because of that, what is happening? So I have equal day and equal night. So here you can see these two lines are equal. This night length and day length. This night length and day length. And here this night length and day length. So all are equal. So that means that is why it is called as equinox. So if you are smart enough, you will understand that the same is applicable here also. Okay. So when you are coming to this location, here also the axis of inclination will be coinciding with the line separating the day and night. So and because of that, here also I will be having equinox. That is 12 hours day and 12 hours night. So this accordingly, I think this is called as March 22 equinox, and this is called as September 22 equinox. Next, we have to go to the next one, that is June 22 solstice. This we have not discussed. We will go for the next discussion. Okay, so I think this we have discussed. That is March and September 22 equinox. So the axis of rotation, it is coinciding. Axis of rotation is coinciding with the line separating the day and night. Okay, day and night. So that is why. Okay, and it is equal. The angle is equal. Even the angle made by the sun's rays, it is equal. Okay, plus 23 and half, it is 66. Minus 23 and half, it is 66.5. Similarly, at the Arctic Circle, it is plus 23.5. So here also minus 23.5. Since it is equal, so you'll be having equal amount of radiation. Okay, but you know this is nearest to the sun, so you'll have a lot of radiation, and at this point it is far away from the sun. You'll have lesser radiation. So you may be thinking, with this small distance, we have a lot of difference. Yes, with this small difference only, all this climate is happening. Okay, this a small difference. Okay, that is because of that only a lot of difference is happening. So that we should understand. Okay, and next is again the day's length. So day's length it will be equal. Okay, it is equal. It will be equal in all the latitudes during the equinox. Okay, whether it is March 22 equinox or September 22 equinox, day's length will be equal. Okay, okay, fine. So next we will go to the June 22 solstice. June 22 solstice. Okay, so now you can see that the sun is inclined. Okay, I'm sorry. So the earth is inclined. Okay, earth is inclined at angle of 22 and a half. And now at this position, okay, I told this position is June 22 solstice. So at this position, you are finding that the Tropic of Cancer is nearest to the sun. Okay, plus 23 and a half north. It is the nearest to the sun. So because of that, what is happening? On the northern hemisphere, okay, it is more exposed to solar radiation compared to southern hemisphere. Exactly what happened here, opposite thing it is going to happen here. Okay, so you can understand. So the Tropic of Cancer is nearest to the sun. Okay, so already I told you. So if you want to remember this and this in a simple terms, here Capricorn is nearest to sun. Here Cancer is nearest to sun. So that is how you have to understand. Okay, so the Tropic of Cancer nearest to sun, that is called as June 22 solstice. So because of that, what is happening? So here you can see this is the axis of rotation of the earth. Okay, axis of rotation of the earth. This is the direct radiation from the sun. Okay, this is the direct rays from the sun. Okay, and now what is happening? Exactly opposite to that of December 22 solstice is happening. Now the northern hemisphere is fully exposed to sun. Okay, and the southern hemisphere is away from the sun. Okay, so this is the line separating the day and the night, and this is the line axis of rotation. So because of that, what is happening? Exactly opposite is happening where we had it in the December 22 solstice. Okay, so the line directly rays from the sun. Okay, it makes 90 degrees to the Tropic of Cancer. So because of that, the Tropic of Cancer will be having maximum radiation. Okay, and next, so we have at the South Pole. Okay, we have all the circles. Okay, so this is South Pole, this is North Pole. So we are finding that here the angle is 90 degrees. So I have at the Cancer I am having maximum radiation. So here the angles are smaller. So that is why at the North Pole. Okay, so at the North Pole I am having maximum radiation. So here you can see here the angle is very much smaller, 43 zeros. So that means below equator I am having less radiation. Above equator I am having more radiation. Okay, I am having more radiation. So that is what we have to understand. And also we should talk about the day's length. Okay, so what is happening to the day's length? So okay, so this also we are, so we are finding that in the North Pole, so we are having 24 hours of daylight, and the South Pole we are having 24 hours of darkness. So that is also most important thing what we have to understand. And the next is in the June 22 solstice, what is happening to the day's length? So exactly opposite to that of December 22 solstice is happening. Now the day's length is higher in the northern hemisphere. So this is the line separating the day, night and day, and this is the axis of rotation. So now I am finding that when I am taking this line, this portion exposed to darkness, it is smaller, and exposed to light, it is longer. So this is supposed to have a longer day length. Okay, So accordingly, I'm having 13 hour 27 minute as the day length at this position. And what is about the night length? The night length is 10 hour, okay, 10 hour 33 minutes, okay. The night length is 10 hour 33 minutes. And when I'm coming to the next slide, okay. So when I'm coming to the equator, so always at the equator you will be having equal day and night length, okay. So 12 hours night and 12 hours day. When I'm coming to the south pole, okay, when I'm coming to the south pole, so my day length is decreasing, okay. It is 10 hours 33 minutes. So my night length is 13 hours 27 minutes, okay. And I'm coming to Antarctic Circle, okay. So the day's length is smaller. It is 5 hours 31 minutes alone, and the night length is 18 hours 29 minutes. So that is what this is important thing what we have to understand, because as an energy engineer, so we need to understand how much will be the day length, how much amount of radiation it will be received. So what should be the climate? So all these details we should be very familiar. So then only we can work easily with the energy simulation software. Okay, so and one most important thing point which we have to remember is the sun is not at the center. Okay, the sun is it will be at the foci. Okay, you will be knowing. So you might have studied about the law of gravitation. So the sun will be at the foci. Okay, so that means the sun will be changing in position. Okay, so that means the sun will be nearest to the earth at the perihelion position. That is during January and December. That is December 22 equinox. The sun will be at the nearest position. So at December 22, Capricorn will be nearer. Tropic of Capricorn will be nearer to the sun. So because of that, what will be happening? More radiation will be there during December 22. December 22 solstice to the southern hemisphere. That is very important. But when you go to the aphelion position, okay, farther away position during July, during June 22 solstice, so you will find that the Tropic of Cancer will be exposed, but the amount of radiation will be smaller when compared to this position. Okay, so this is one important point which we have to understand. Okay, so I need to mention here. Okay, so now that we have understood about all the 4 positions. Okay, so we have 4 positions. One is December 22 solstice position. The other one is the June 22 solstice position. The next one is March 22 equinox position. The next one is September 22 equinox position. Okay, so what is happening? So first we will go from hemisphere to northern hemisphere. What is happening to the northern hemisphere when I am moving from September to March? Now that we have passed September, okay, so we are going towards March, next year March. So what is going to happen in the northern hemisphere? So in the northern hemisphere, you are going to find from 12 hours, okay, so you are going towards, okay, a reduction in the day's length, okay. So that means the northern hemisphere is subjected to a cooler cycle. Okay, northern hemisphere is subjected to a cooler cycle when I am moving from September 22 to March 22. Okay, and similarly, when I am moving from March 22 to September 22. Okay, so what is happening? The northern hemisphere is subjected to a warmer cycle from 12 hours. Okay, it is going to 18 hours and it is going to 13 hours. So that means more radiation on the northern hemisphere. So because of that, it is subjected to a warming cycle. Just relax and try to understand. So all of us know when the September starts, we are marching towards December. That is winter. Up to March, December will be. Winter will be there in the northern hemisphere where we are. And once March has started, we know that after that we will be having the sun. Okay, we will be having the summer. Okay, after that we will be having the summer. And after the summer, again when you come back to September, so that is what we call it as warmer cycle. Okay, in the northern hemisphere, from September 22 equinox position to March 22 equinox position, this will be subjected to a colder cycle. And similarly, from March 22 to equinox position to September 22 equinox position, so northern hemisphere will be subjected to a warmer cycle. Okay, now we will go to the southern hemisphere. Exactly opposite thing will be happening. In the southern hemisphere, when I am going from September 22 equinox to March 22 equinox, the southern hemisphere will be subjected to a warming cycle. Southern hemisphere will be subjected to warming cycle. So that we may not understand. Okay, so only people in the southern hemisphere they will appreciate that. Okay. Similarly, when I am going from March 22 equinox to September 22 equinox, the southern hemisphere will be subjected to a colder cycle. Okay, southern hemisphere will be subjected to a colder cycle. Okay, so this is the basic concept which we have to understand for understanding about the seasons. So that means we are ready to understand about the seasons. Okay, so this is what I have given in the form of. So from September to March, the northern hemisphere undergoes a colder cycle depending on latitude. So it depends on the latitude. Okay, so if you are at very near to the pole, the amount of coldness will be higher. Okay, so that's what I mean by that, and the day's length will be shorter. Okay, on the latitude. Similarly, when you are going from March to September in the northern hemisphere, we will be having warmer cycle that I have explained, and that also depends on the latitude, and the peak will be at June 22. Okay, so this is very familiar for us. Northern hemisphere, it is very familiar for us. Okay, because we are at the northern hemisphere. But the southern hemisphere, when you are going from September to March, the southern hemisphere will be undergoing a warmer cycle. Okay, depending on the latitude, and the peak will be at December 22. So the exactly opposite. We will be having peak cold at December 22. Southern hemisphere will be having peak warmness during December 22. Similarly, from March to September, the southern hemisphere will be undergoing a colder cycle. It will be undergoing a colder cycle, and the latitude peak will be at June 22. So the day's length will be shorter at this latitude. Okay, so that is what we have to understand. So this is an important concept which we have to understand. So what about the seasons? Okay, what about the seasons? So when I am having a Jagarajan, I think somebody is having a mic on. Please check that. Okay. Okay, so I will continue. So this is the thing. Okay, so how we are having at the seasons. Okay, now again at the northern hemisphere. So when I am moving, okay, so we know that during December 22 solstice in the northern hemisphere, I am having winter. Okay, and I'm going towards equinox. Then I am going towards the summer. Okay, so in June 22 and the northern hemisphere, I am having summer. Okay. Okay, when I am going from winter to summer in the northern hemisphere, on the way definitely I should have the spring. Okay, so that is happening at the equinox. So at the equinox, March 22, I will be having the spring. So that means December 22, we are in the colder cycle. That is northern hemisphere is in the colder cycle. That is from the winter, we are going towards summer. On the way, definitely we will be having spring. So March 22, we will be having spring in the northern hemisphere. That is what we have to understand. Okay, fine. So similarly, from in the northern hemisphere at June 22, we are having summer. Okay, June 22, it is June 22 solstice. We are having summer in the northern hemisphere. So when I am moving toward from the June 22 summer, from the June 22 summer, when I am moving towards the winter. So in the northern hemisphere, I will be moving from summer to the winter. So that means on the way, definitely I should have autumn. So autumn, I call it as the fall in the northern hemisphere. Okay, fine. So next, when I am moving, we will go to the southern hemisphere. When I am going to the southern hemisphere, so during December 22 solstice, I will be having the summer. So during December 22, I'll be having the summer, exactly opposite to that. So that means from the warmer climate, I am moving towards the winter climate. Okay, when I am moving from the warmer climate, I am moving towards the winter climate. So when I am moving towards the winter climate, so on the way, I will be having from summer to winter, I will be having autumn in between. So because of that, I am having fall. That means March 22 equinox, I will be having fall in the southern hemisphere. Okay, so I'm moving from summer to winter in the southern hemisphere. So on the way, definitely I should have autumn or fall. Okay, similarly, I'm moving from June 22. June 22 is winter in the southern hemisphere. From there, I am going towards the summer in the southern hemisphere. Okay, when I'm going from winter to summer, on the way in the southern hemisphere, on the way I'll be in the spring. So okay, so that is how I'm having various seasons on the surface of the earth. So now we should know how we are having winter, how we are having summer, and how we are having spring. Okay, at the various seasons. Okay, so that will be helpful for us to understand while doing the energy simulation. Okay. Okay, so apart from the subject, so we will discuss about a tourist destination. So when you are at the 40 degrees north latitude, okay, so think that you are at the 40 degrees north latitude. So that means you are in the Scandinavian countries or in the China. Okay, so during December 22 it will be winter for you, extreme winter for you. Okay, so if you want summer, where you have to go? You have to go to uh, 40 degrees south latitude. That means we have seen South Australia or south of South America, or there we have to go, because there they will be having the same time they will be having the summer. Okay, okay. Similarly, during June 22, okay, June 22 solstice, so you will be having winter in the south of Australia. Suppose they want to go for, want to have summer. Okay, so where they have to go? So June 22 from Australia, South Australia, they have to go to uh, 40-degree north latitude. That is, they have to go to Europe, Scandinavian countries, or US, or they have to go to China. So that is how you may be knowing. So now you have to think, okay, what are all the possible destinations? Okay, possible destinations with good climate, with summer, because you know Europeans, they will be loving the summer. Okay, Europeans and Australians will be loving the summer. So what are all the destinations you have to go? So this is how you have to think. Okay, so 40-degree north latitude, if you are there, you have to go to 40-degree south latitude if you want summer. Similarly, if you are at 40-degree south latitude, okay, you are in winter, you want summer, you go to 40-degree north latitude. So that is how, this is a rule of thumb. Okay. Okay, so next we can go to the sun path diagram. Okay, so we are going to the subject. Okay, so most of us, you know, when in the energy simulation software, there will be a sun path diagram. Okay, so most of the software, they will be giving the sun path diagram. So what is the significance of the sun path diagram? Okay, so now that we have understood about the climate, we should be in a position to know about what is the sun path diagram, how we have to understand. Okay, so a typical sun path diagram, it is given for 40-degree north latitude. Okay, a typical sun path diagram, it is given for 40-degree north latitude. Okay, we are finding. Okay, so this is a equatorial plane. Okay, so this is the axis of rotation. So this is equatorial plane, and this is tropic of Cancer position. This is tropic of Capricorn position. My location is on 40-degree north latitude. So almost you think that North India or beyond that China. Okay, beyond that we are at in the Chinese climate. Okay, so how it will be? Okay, how it will be? Okay, so we are finding that now that we know about the equinoxes, December 21, it is December 21. It is a tropic of Capricorn, so it is solstice. Okay, and similarly June 21. Okay, so it is another solstice. Okay, and March 21 and September 21, it is equinoxes. Okay, so it will be at the equator. Okay, it will be at the equator. So when sun location is at 40-degree north latitude, so you find that during summer the day length is higher. You can see the sun path from here, it moves like this and it goes like this. Okay, so that means the day length is more during the summer, because of obvious reason what we have seen already, and the day length is equal in the at the equator. Okay, so you are having an equinox, so day length will be equal. And when you are going for winter, that is December 21, since you are in the north latitude, okay, December 21 will be winter for you. So at that point of time, what is that you are finding? The day length is smaller. Day length is smaller. Okay, that is what you are finding. And one more most important thing, what you are finding is the sun is always there at the south only. Sun is not coming overhead. Sun is not coming overhead. Sun is always there at the south only. Okay, so you are located at the 40-degree north, but always the sun is at the south. Sun rises at the southeast and the sun sets at the southwest. Okay, if it is December, it is at the extreme southeast and extreme southwest. If it is equinox, it is somewhere in between. Still, it is southeast and southwest. But during summer, it is nearer to the upright position, but still it is southeast to southwest only. So that is what we have to understand. Simply because this is very important when you are designing the building. Okay, where from you are going to absorb solar radiation. So the sun is going to be always there at the, when if you are at the 40-degree north latitude, sun is going to be always there at the south latitude. So that means you have to put your glass and the collection point at the south. So this discussion becomes important. Okay, and I think sun is always, so I think all these things I explained here. And also that we are finding the building will get the solar exposure only in the south direction. There will be no northern exposure throughout the year. Okay, You have to design the building accordingly. Suppose if you have your building located at 40 degrees south latitude, so what will happen? Exactly same like this only it will be happening. The sun will be always there at the south north latitude. If you are at 40 degrees south latitude, the sun will be always there at the north latitude. Okay, so during summer it will be nearer, okay, nearer to Capricorn. Okay, during winter it will be nearer to Cancer, Tropic of Cancer. So that means always it will be the sun will be always in the north, but it will not be overhead. So that is what we have to understand. Okay, so all these things we can understand when you put the sun path diagram. Okay, so these are all the typical and interesting sun path diagrams which we need to understand. Okay, so first we will go to the sun path diagram in the equator. Okay, in the equator, what is that we are finding? Okay, so in the equator, so we have three positions. I told you about three positions. Always you should remember about these three positions. One is December solstice, another one is June solstice, and the other one, two equinoxes. December 22 solstice, that is sun is nearer to Capricorn. Okay, June 22 solstice, sun is nearer to Tropic of Cancer. So equinoxes, okay, the sun is near the equator. Okay, so three positions. So here they are given three colors. You can see this color is for June solstice, and this color, red color, is for December solstice. For equinoxes, it is blue color. So this red color, it is for December solstice. Okay, so when you are in the equator, it is very simple for you. So always the day length is equal. Okay, whether your sun is in Tropic of Capricorn, the Tropic of Cancer here, or if it is in the Tropic of Capricorn, so always the day length is same. We find that always the day length is same. Okay, even if the equator, the day length is same. Always it rises at morning 6 a.m. and it sets at 6 a.m. Okay, no southerly exposure, no northerly exposure. Okay, it is you can see it's very interesting. Okay, at the equator, so always the day's length equal, and the sun will be overhead only. Okay, and this represents the December 22 solstice. Okay, so that means the sun is the Tropic of Capricorn. Okay, so near in the north, you are at the extreme. Okay, so that is how. So then I have June 22 solstice. Okay, so there also. Okay, the sun position may change. Okay, but it will be overhead only. Always it will be overhead only. Okay, but you try to compare this with 50-degree north latitude. Okay, now before this we have seen 40-degree north latitude. You compare this with 50-degree north latitude. For 50-degree north latitude, okay, you are at the north. Okay, so that means the sun will be in the south. Okay, the sun will be at the south. So this red color. Okay, so this is December solstice. Okay, so that is obvious. So the sun will be at the Capricorn. So that means at extreme position. Okay, that is the extreme position. You can find the day length is smaller. When the day length is smaller, you find that the sun is rising at 8:10, almost 8:09 a.m. Okay, when it is setting 3:51. So the day length is smaller. So that means from 6 it goes to 8:09, and the sun while setting, okay, it is around 3.51. Okay, 3:51 p.m. Okay, the sun is setting. This is during winter. This is during the winter. Okay, and when you are going for the equinoxes, so the sun will be there's no other go. Sun has to start at 6 a.m. and does to go down at set at 6 p.m. Okay, when you are going for June solstice. Okay, when you are going for June solstice, during June solstice, the sun will be at the Tropic of Cancer. Okay, so that means you are at the north, means the sun will be at the north. So you are finding that the day length is increased. So now it is not 6. The sun is rising at 3:51 itself. The sun is rising at 3:51 itself. Okay, and when it is setting at 8:09 p.m. Okay, 8:09 p.m. Okay, so 8 o'clock at the night only the sun is setting. So when you are living in the 50-degree north latitude, you will observe all these things. Okay, so during summer, okay, so the early morning, okay, the sun will be rising at the early morning 3:51 the sun will be setting at 8 9, okay, night time. During a winter, okay, so you will be having a smaller day length, so the sun will be rising only at 8 o'clock and the sun will be setting at 3:50. So this is something interesting. So this is, we are not familiar to that because we are living in between 10 degrees and almost 30 degrees north latitude, okay, so we are not very familiar with this. But we know when we go to Delhi, we may be experiencing this to a smaller extent, okay, but beyond Delhi, if you go to China and other places, Russia and all, okay, so this type of extremities we can observe, okay. And most interesting, okay, the most interesting than that is when you are at 90-degree north latitude. What is the meaning of 90-degree north latitude? 90-degree north latitude means that means that you are at the North Pole. You are at the North Pole. What is happening at the North Pole? So in the North Pole, so you will find that the sun, okay, so this is June solstice. This is June solstice, one extreme position, and this is equinoxes. You know that at the North Pole, the sun will be there only for 6 months. So this is for this obvious reason. You should know that. So here you can see, in this diagram you can see at the North Pole, okay, in the North Pole, we will be having a extreme darkness here, but here you will be having a daylight. So that means for the 6 months, okay, only we will be having the daylight here, and the 6 months you will be having a darkness here at the poles. 6 months it will be darkness, 6 months it will be daylight. Similarly, when you are crossing this equinox coming here, this will be 6 months, it will be daylight, and 6 months it will be darkness, okay. So that is what is represented here, okay. So that is what is represented here. So what is happening when you are crossing one equinox, okay, that means you are coming, the sun is coming to the northern hemisphere. When the sun is coming to the northern hemisphere, it will be June solstice, okay. Sun will be coming to the northern hemisphere during the June solstice. So what is happening after that? Okay, so the sun will be making rotation. If you are going to the North Pole, you will find that the sun will not rise and set. The sun will be rotating in the sky. The sun will be rotating in the sky. Okay, so that means at the equinox, okay, so at the equinox, before the equinox, okay, it will be at the South Pole. After that, when it is coming at exactly equinox, it will be coming towards the North Pole. So that means the sun will be rotating like this, okay. And after that, okay, from the equinox to the June solstice, the sun will be rotating like this only. It will be rotating, and it will be going at June solstice, it will be rotating. What is the meaning of rotating? Literally at the sky, you can see that morning 6 a.m. the sun will be rising, and it will be moving horizontally in this direction at the noon like this. And the evening, okay, so it will not be setting. It will be at this location. And after that, there is no night. There is no night. From there, it will be, we are mentioning it as midnight. There is no midnight. Again, the sun is visible to everyone, okay. So it will be rotating from here, it will be rotating. So that means for the 6 months, the sun will be rotating, except that at the equinoxes, it will be at the ground level. That means it will be always like evening, okay. From east to west, it will be moving along the surface of the ground, okay. So that will be like always like evening sun. And after that, what happens at extreme June solstice, you will find that it will go to that position, okay. It will go to the position. From morning, it will be moving in one direction, and exactly in the evening, from the evening, it will be moving in the opposite direction till the next day morning, okay. There is no night here. It is shown as midnight. There will not be night, okay, because all the time the North Pole, it is exposed to the sun. Exactly same thing will be happening at the South Pole also, okay. After from here, what will happen? The sun is traveling from here to the from equinox to June solstice. It will be traveling here, okay. And again, from after June solstice, from there it will be going towards the equinox, that is September. And from after that, what will happen? The sun will disappear in the North Pole. Now it will be going to the South Pole. So that means what? It will be fully dark only, okay, no daylight at all. It will be fully dark for 6 months, okay. Then what will happen? The sun will go do the same thing in the South Pole. So it will be making rotation in the South Pole, okay. It will from the equinox, it will go to the South Pole, and again it will have the December solstice. From there, it will be coming back, okay. From there, it will be coming back again at the equinox. It will start to come to the northern hemisphere. So it is something interesting. Okay, so that we should know. Okay, sun path diagram, it's very important and it's very impressive. Okay, so now that we had some interesting discussions on the solar positions and the climate, so what is the takeaway for the building energy simulation engineer? Okay, so what is that we are finding is beyond the Tropic of Cancer, all buildings will have only south exposure throughout the year. So that we have seen a case of 40-degree north latitude and 40-degree south latitude also. So that means beyond the Tropic of Cancer, all buildings will have only south exposure throughout the year, and the intensity of solar radiation will be more on June 22 and less on December 22, because that is June 22 solstice. Okay, and it will be less during December 22. Okay, when you are in the north latitude, it is typical for us. Okay, when you are beyond the Tropic of Capricorn, that is in the southern hemisphere, okay, you will be having only north exposure. See, very clear. If you are beyond, so it is not 23 and of north and 23 and of south. If you are beyond 23 and of north, okay, you will have only south exposure. Similarly, if you are beyond 23 and of south, you will be having only north exposure. So think about a case exactly opposite to that what we have discussed. We have discussed north, 40-degree north and 50-degree north latitude. You think of a case of 40-degree south and 50-degree south latitude. So all the exposures will be in the north only. Okay, so that's very easy to understand. If your building is lying between the Tropic of Cancer and Tropic of Capricorn, it will have exposure both in south as well as north, depending on the declination or the movement of the sun. It will be having exposure both at north as well as south. Okay, so building at the equator, will be having equal exposure. Okay, so building at the equator will be having a 6-month north exposure and 6-month south exposure. Okay, and these things I think it is known to you. And building at a 15-degree north latitude, so almost like in India or our condition, maybe Andhra will be having a 50-degree north latitude, and this will have more south exposure than north exposure throughout the year. Okay, so building at a 50-degree north latitude will be having more south exposure than north exposure. For example, if you take Chennai also, so most of the time the sun will be at the south. We are at Chennai, it is at the 13-degree north latitude. So that means most of the time the sun will be at south exposure. Only during the time of maybe May, June, July. Okay, so you will be having a northern exposure for a 50-degree north latitude. So that means most of the time, that means 3/4 the time the exposure is on the south, and 1/4 the time the exposure is on the north. So if you understand the logic, okay, so then it is easy for us, for you to design the buildings. Okay, and similarly, if your building is at a 15-degree south latitude, it will have more north exposure than the south exposure. So this is also obvious. Okay, so if you are at the 15-degree south latitude, most of the time your sun will be at the north. Okay, and only maybe 3 months, maybe December or other 3 months, it will be going to the other exposure. Okay, November, December, and January, it will be going to the other exposure. Okay, so this is very important. So now you should understand climate. Understanding climate is very important for applying the building simulation problems. And these already I told you, we are going to give all these climatic parameters as the input to the building simulation software. So climate of a place decides the cooling and heating requirement of the building. So as a building design engineers, all of you might be knowing. So climate of a place will decide how much cooling or how much heating will be required for a building. And similarly, a building simulation climatic model, it is given as input. Already I told you. So energy requirement is calculated as the output from your building simulation software. Similarly, building energy requirement, it depends on the climate. Okay, extreme climates will be requiring more energy. It may be heating or it may be cooling. Very extreme cold will require more heating, and extreme hot will require more cooling. Okay, so it is a duty of a building simulation engineer to isolate the building from a climate extremities and to minimize the energy consumption. Okay, so we have to minimize the energy consumption, and also we have to utilize the solar energy usefully for heating of building and during the colder countries. In a colder place, we have to use solar energy for heating. Okay, so that is what we do, and we have to go for passive solar design. Okay, passive solar design in a hotter climate for cooling. Similarly, you have to take in the solar energy for heating. Okay, in a colder climate. So that is how your building design should be. Okay, So these are all the takeaway from the building energy simulation. This today's discussion, and thank you for your patient listening. So now I will answer your queries. Okay, thank you. So any query is there, I am here to answer. Okay, just 1 minute, or somebody can read. Somebody can read from the chat if there is any question. Okay. Okay. Any question is there? All the participants, are you listening? First of all.
Yes, sir.
Yes, sir.
Yeah. So you can post your questions. Okay. So I completed today's discussion.
Nice, sir. Nice.
Yeah. So the sun path diagram in the Norway. So Norway, I think it will be in the 40-degree north latitude only. So I think we have seen 40-degree north latitude and 50-degree north latitude also we have seen. Okay. So it will be like that only. If you want to do it specifically, you can do it in the building simulation software. It can be done. If you want, I can show it tomorrow. Okay. For Norway, the sun path diagram, I will show it tomorrow. Okay. Just I will note it. Okay. Yes. Any other question is there? Oh, you want me to repeat about autumn and the spring season? Okay, 1 minute. 1 minute. I'll. So I'll repeat. We have discussed about 4 positions. So one is December 22 solstice, and the other one is June 22 solstice, and 2 equinoxes. Okay, when at December 22 solstice. Okay, so you know that the topic of Capricorn will be nearest to the sun, and northern hemisphere. Okay, in the northern hemisphere we will be having winter. In the southern hemisphere we will be having summer. So when you consider northern hemisphere alone, okay, when spring will be there for northern hemisphere. So when I am moving from December 22, okay, so I have winter here. So when I am moving along this path, so that means from December 22, I am going to March next year, and after that I am going to June 22 next year. So that means when I am going from winter to summer, okay, on the way I should be having a spring. Okay, so that will be happening in the March 22. So December 22 I'll have winter. Okay, so from there, and in the northern hemisphere, and March 22. Okay, so when I'm moving from this position, I'll be going to March 22 equinox. In the northern hemisphere, I'll be having spring. Okay, and similarly, when I'm moving from spring, I'll be going to summer. June 22, I'll be having summer. That is known to you because the sun is nearer to the Tropic of Cancer, so it is in the northern hemisphere. I'll be having summer. So when I'm having summer here, so from June 22, when I'm moving from June 22 to December 22, so I have to cross the September 22. So September 22, it is a equinox. So at that point, I'm moving from summer to winter. So in between, I'll be having autumn. So all of us will be knowing when I'm moving from summer to winter, in between, I'll be having autumn. Similarly, when I'm moving from winter to summer, I'll be having the spring. So in the northern hemisphere, okay. So in the northern hemisphere, so when I'm moving from summer to winter, so on the way I'll be having the autumn. So that's called as fall. Okay, and exactly opposite discussion will be there for southern hemisphere. In the southern hemisphere, okay, in the southern hemisphere I'll be having a summer during December 22. So when I'm moving from summer to winter, June 22. So on the way I'll be having the autumn. Okay, that will be on the March. Okay. So similarly, when in the southern hemisphere, when I'm moving from winter to summer, from June to December, on the way, I'll be having spring. Okay, in the southern hemisphere. So the discussion for northern hemisphere and the southern hemisphere, it has to be discussed separately. Then only we will be understanding. So we should not mix both the things. Okay. Thank you. Okay. Any other question is there? Whether there is neither summer nor winter at equator throughout the year. No. See here. Okay, 1 minute. I'll explain through the PowerPoint slide. Okay, so we have the slide in the discussion. Okay, at the equator. So here you can see. during equinox, okay, so the sun will be overhead. So that means we will be having a maximum solar radiation. That will be very hot, okay. But we have extreme positions also. So one at June solstice, comparatively it will be cooler because the sun is moved from the overhead. So June uh, June solstice, okay. So during June solstice, so the sun is not overhead, so it will be comparatively cooler. Similarly, December 22, that is the summer solstice, that is also far away. So that means it will be comparatively cooler. But if you compare it to this case, so this case will be extremely colder. Okay, so this when you go to 50-degree north latitude, it will be extremely colder. So all these things will be colder, but this will be a pleasant summer. Okay, but here it is very hot during the summer. That is equinoxes. It will be very hot during the solstices. You will be having a better climate. Okay, you will be having a better climate during June solstice as well as December solstice. Okay, so you will have a better climate at the equator. It will not be very hot, but it will be relatively hot only. Okay. So any other question is there? Yeah, so I'm going to discuss. Okay, so don't worry, Google or the climatic condition also depend on local climate, how to handle while calculating heat loads. So I am going to discuss in detail. Okay, so that the background and all everything, heat load calculation and the energy simulation, everything I am going to discuss. You need not worry. Okay. So any other question is there? How sun radiation in Gujarat in December month? So Gujarat, I expect, I think it may be around 20 degrees or 50, not 15. Okay, so it will be around 20 degrees north latitude. Okay, so that means during December it will be cold only. Okay, so during December, so almost all North India it will be cold. But if you compare it with Delhi and other locations, okay, so it will be a little bit warmer. Okay, but Delhi will be colder because you are going to the next latitude. So if you compare it with China, okay, so still it will be colder. Okay, it is like you compare Chennai with Gujarat. Chennai will be lightly, you will be having a pleasant climate. Compare it with Gujarat, still you will be having colder. Okay, but if you compare it to Delhi will be more colder than compared to Gujarat. So it is relative. Okay, because of the latitude only. Because of the latitude. So if you are going away from the equator, so you will have extreme climates. Okay, so it starts with Delhi and China and further Russia. So like that we can go. Okay, so any other question is there? No. So 20 degrees, 30 degrees, it refers to the latitude. Okay, so it is not referring to the climate. So from that latitude, you have to work out. So for example, if you are going to a building simulation software, so you give the latitude and the longitude, latitude location. So automatically it will give you the sun path diagram. So you need not worry. So from that you can understand. So latitude represents the location. Okay, but the climate is decided by the relative position of the sun towards to that latitude. Okay. Yeah, so I think I have explained. Okay. Does equator region will have 2 summers? There are 2 definitely. It will have 2 summers only. Okay, because you are having 2 equinoxes, definitely it will have 2 summers. No doubt about that. So I think I have answered all the questions. Okay, so I think any other question is there? Yeah. So tomorrow we will have our next discussion. So our next discussion will be on the heating and cooling of buildings. Okay, so that will be the next discussion. So I think all of you can join for tomorrow's discussion. So don't worry about your Google Meet. If you are not able to join the Google Meet, don't worry. I think streaming is going on in the YouTube also. Okay, so I think most of them they are visiting that YouTube streaming also. So don't worry.
Sir, two questions from YouTube chat, sir.
Oh, okay, you can tell the questions, I will answer.
Which is best simulator for building simulation?
So I will not tell you. You have to see. Most of them they are using building. I think design builder like that. Most of the softwares are there. So, but I should not tell. Okay. So in this I cannot tell. You ask me separately. I will tell you. Okay. So it is
Sir,
not correct to tell you.
another one.
Yeah.
Is solar tracker feasible in building automation?
Solar tracker is building automation. Solar tracker, I think you can do it. No, now you know the sun location. So if you are tracking the sun location east to west as well as north south. Okay, so just you have to automate that. Okay, you know to east and west movement for a location. You know you can know the sun path diagram. So just you are going to imitate the or copy the sun path diagram. Okay, depending on the day. You know that the sun path diagram depends on the day. Okay, so December 31, June, December 22, June 22, the sun paths will be different. So that means for each location, if you just imitate what is the sun path diagram, you will be getting maximum radiation. Okay, so that you can automate and do it for solar tracking. You can do it. Yes. You can go to next question.
That's also.
Jagarajan, you have a few more questions? That's all, Jagarajan?
Sir, in YouTube question. Sir, is it possible to take up your case study in near future for software skills? Cannot find.
Yeah, you can do it. Yeah, you can do it, but I cannot do in this one. Okay, so you can do it. You can approach me. You can do it. Okay. Software learning is very simple. It is not a very big deal. Okay, you can do it always. But learning the concept is very important. Then only you can become a best simulation engineer. Okay. Yeah. So any other question is there?
That's all.
That's all. So if there is no questions, thank you everyone. Okay, thank you for joining for today's discussion. I hope this today's discussion will be useful for you. If you have any doubt, okay, so that you can send me in you can post it in the WhatsApp group. So we have a WhatsApp group. You can post all your doubts in the WhatsApp group. I'll be very happy to answer all your doubts. Okay. So tomorrow we will meet for the next discussion, that is heating and cooling of buildings. Okay. Thank you everyone. Thank you for joining.
The participant won't feedback link in the.
Sir,
Thank you, sir.
further questions you can put it in the chat, WhatsApp chat box. So I will join in the WhatsApp chat box in a few minutes. So there I will answer all your questions. Okay. So we will stop our chats here. We will continue our chats in our WhatsApp discussion. Okay. So I will be